Welcome to Module 8, Chapter 18. We got 2 more chapters to go, 18 and 19. 18, we have the PowerPoint. Normally my lectures run through the PowerPoint. This one, I'm going to go through the chapter a little bit more in the book, hit the highlights of the book versus the PowerPoint. There's a lot to be desired from just the PowerPoint itself, but let me share my screen and I'll hit the overview of the PowerPoint, but I'm mainly going to focus on the chapter headings or subchapter headings in 18. It's all about building construction surveys and things that surveyors have to stake out for buildings. And while you would not do any of this for construction management, it's a good thing to know about. The liability is too great for you to be working on something like this as a construction manager, but you need to know what's necessary. So we'll go ahead and share this screen. Hang on just a moment. Let's get the slideshow going. All right. And here we go. All right, we're sharing now. All right, so we have Chapter 18, Building Construction Surveys. We don't have too many slides to get through. So what the book is trying to show you here is some things that really surveyors wouldn't use. These are very, very rudimentary. This refers to a location drawing. In Maryland, the location drawings are something much different. They are utilized for refinancing or getting a mortgage on a house. That's what location drawings are used for. So this is just a drawing showing you various buildings where they sit on next to roads and how they relate to each other, but there was no dimensions or bearings or distances, and that's what surveyors actually produce. This, again, it's called a location drawing. If we were to zoom in here, it's not that important. This is more of where a building is going to, a new building is going to go on a site. And it'll tell you here a variety of different information on the bottom. It says a site plan. Again, this is not really a site plan for anything you would see in Maryland or anything you would see in construction or even a single family house. You would see a lot more information than on that particular slide. Here, we're looking at a floor plan. This is something a little bit more like you might see in a single family home or a single story type commercial building. This is, like I said, it's a typical floor plan, but you would be able to utilize the outside of this to compute the building and the size of the building. And so you could utilize a plan like that for your staking out a building. These are elevations. In other words, they show the face and sides of a building. So if you look at something like this, you have doors going in, you have all sorts of windows, some concrete panels here on the outside of this building. So it tells you the type of surface. Here's your roof height. Usually there's a dimension here that I can't read from the roof down to the top of the first floor. So this is a typical elevation. That's what they're called. It's where you see the sides of a building. And typically you have all 4 sides of it visible to you on a set of plans. Even for a set of house plans, you would want to see all 4 sides of a set of house plans. So this is something a little bit more, it's a building layout. It's already been computed and these distances are shown. And this is a diagram of something that would be of a way somebody would stake something and lay it out. So these are batter boards. And this whole thing is talking about batter boards. And you can see right there what a batter board is. And I never use them. Maybe construction people use them more. A batter board is a solid board that's fixed in here that holds a string line at a certain offset, so that what happens is as you pull this string line over to here, the surveyors have given usually multiple offsets. They usually do 2 offsets in certain corners if it's a big building. If it's a smaller building, they'll give you like 1 here, 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 and then they'll extend this line till it meets this one, and they'll give you an offset for that point. And what happens is we have these string lines that are pulled through, and wherever they intersect is where you have a wall line and a corner. So this wall line, it runs with this piece of string, but it stops where it intersects another piece of string. So that's the effect of what batter boards would do for somebody laying out something for a footer, or for block to go in, or a concrete wall to go up. It's still similar techniques used today. I don't know that people necessarily use this one anymore with the batter boards. Here's a picture of the steel columns. Surveyors would stake this column line, and they would stake these column lines. And again, the intersection of column lines would be the center of these pillars that you see right down here. And then at that point, construction crew would mount and put in the anchor bolts for these steel beams. Surveyors actually never stake out anchor bolts, or I should say very, very rarely would a surveyor stake an anchor bolt, but they do stake out these column lines. Just another picture of the column lines, single story building, and you see all this concrete, all of this rebar up here. What that tells me is that we're going to be looking at a concrete roof, and that's all the, I guess, you tie the rebar together to strengthen the concrete. That's what we're looking at there. Um, this is a laser level, or an electronic level, and he's got a little target there that would tell him the height that he's at anywhere along this path. So this thing spins in a circle, and he has this rod over here, or this card that reads it, the height of it. So wherever it hits that, he knows a certain elevation, and he can mark it to check these poles, or check these columns, or anything else you might need to do with it. But this is a little old and archaic, but the idea is the same. Machines are newer and look better, and they're smaller, but they sit and spin round and round pretty quickly, constantly projecting a beam out, a light beam, that when you hold a target and it correctly hits it in the right spot, then you know the elevation that you're at. There's a smaller version. This is something that we see more often, where you actually have this attached to a stadia rod, and you would move this up and down to hit that beam, and then you could do the math and figure out where you're at. So it reads the stadia rod. Well, it doesn't. It tells you where it's level. You still would have to read the feet and tenth marks on the stadia rod. And in fact, this is a very weird one because it's actually in inches. So maybe some carpenters have that, but they usually don't. Again, it's just all right, here's where I'm going to stop the slideshow. And I'm going to come back, and we're going to look at we're going to go through the book, and then we're going to get into this, because this part of things is a little bit more interesting, and I want to give you things that are useful. So let me stop the share for just a bit. And so we sort of gave an overview of those slides, and that gets us through, somewhere in the middle of the first 4 or 5 pages of the chapter. One of the things I want to point out is at the bottom of page 499, it talks about a surveyor staking out a building, And after the corners have been staked out, it talks about measuring the diagonals. So when you stake out a square, you want to make sure it's really square, you can measure across the diagonals of the square. And what you're doing is you're really measuring the hypotenuse of a right triangle. And so the little formula that gives you down there is that's Pythagorean theorem at the bottom of page 499. And it is a useful tool still, and especially is very useful if you're in construction management and you're out there in the field someplace checking something. Is utilize that Pythagorean theorem and check your diagonals to make sure that something is put in square. Surveyors have gotten away from it over the years, but it still is a very, very useful thing. And I mean, I use it when I'm trying to build things around my house, like a deck or some sort of platform or something that I'm trying to build. I will actually still use the same technique to make sure that I'm squared, or a shed or anything like that. Again, looking at your book, the book kind of was all these slides sort of covered up until looks like about a little further than I thought. All right, until we get up to about 510 or so. Yep, 510. So in page 510, so we start in 18.3, talks about multi-story construction. This is now different. This is a game changer, and hopefully if you get a job in construction management, you land a job where you have a multi-story building, because it's pretty cool. It's pretty cool watching them go up. There's a different technique involved all the time, and it's a lot more work, but it's nice to see floors go up and things get built. So when you're dealing with multi-story, from a surveyor's perspective, we have to maintain the control as the building goes up. You don't continue to use the control that's on the ground every time a floor gets built. And right now, what I'll do is I'm going to go back to the screen share just real quick, and we'll see here. So right here, you see that this guy is already on the third floor. This is set up on the third floor. We've got a crane. This is something you would have around the cities, not too much down here in the rural area, but it's possible. You have a crane that's doing various things. But when you put in this first floor, the surveyor would have points on the ground, just like we've been talking about. And then they go ahead and they build the first floor and they put the second floor in. The steel, you don't get a steel beam that goes up through every single floor. What you end up doing is you come back on the second floor. Now, if you're doing a 2-story building, you can probably get a steel beam that will cover 2 stories. If you're doing a 10-story building, you will not get a steel beam that covers 10 stories. So you would come back in and you would set your control again, and you'd stake out these points on the third floor. Everywhere a steel beam was going to have to be placed to support the structure going up, and you would have to stake it out. Now, how do you do that? Well, you end up just like this. You end up here with your total station, not at the Autolite anymore, but your total station just in the middle of the building somewheres, and you have targets all around. And I think there's a better picture coming up. Let's see. Yeah, here's a little bit better. Well, yeah, this is a better picture. Again, you would not be using a theodolite, and you would not be using a steel tape as it's pulled across the building like that. You still would use a total station and a prism for this. You could use a steel tape to check things. It's going to be faster, and your electronic data collectors are going to want to see a prism when you're out here, and that's fine. But this method, they call it wiggling in. A better term is something that was called resection, where you don't actually cite steeples and buildings far away, you can do that. But what you actually would have is you would have control all along the ground like this. You have points out here on the ground safe from your site. You can have a spot over here to check like that, but really you cite these. So when you sit up here, you know where all of these are. And you go ahead and you shoot them all. You shoot these three, you might as well shoot this one, this one, this one, and turn a check to that. And then data collectors nowadays, and certainly can do it in a computer, you take the average of all of this information and you figure out where you are right there. Each one of these is a triangle that you can figure out your position. Once you're satisfied with where you are right there, you can cite one of these and start turning angles and distances to set the corners of the building and keep going up. So that's how a multi-story building works. I have actually never done it. Being here in Southern Maryland, it's not something we do very often. But it is very interesting, and I think it would be kind of neat to do it one time. I've talked to people that have done it. I knew some people that staked out the National Harbor and like the Gaylord, the multi-story there, the Gaylord and the hotels. And this is how you do it. Uh, you know, Now you could possibly even utilize the GPS a little bit, but you better be very careful with that as well. All of this is very, very careful, and you have to survey very well to establish that control on a new floor. So that's pretty much going to wrap up chapter 18. And again, it's about how you stake out buildings. And basically, whether it's one floor or 20 floors, you're still going to have the same per floor stakeout methods. The only real difference is that when you're staking out a multi-story building like we just saw with concrete floors, you're not going to offset the building corners like you do on a single-story building. When you offset these corners, or even like a 2 or 3-story building, depending on how it's built, you don't really stake out floors too much on those. But the bigger buildings with concrete floors, you stake out the floors. Well, you do it directly. You put points in such that somebody can utilize them for the steel columns, and your offsets are not very much. I mean, and they're column lines. So that's it for chapter 18. I'll be right back in a few moments with chapter 19.